Okay, this is the quiz preview for, actually, it's not quiz 8, it's actually quiz 9 because I renumbered them because the graphing quiz was called the graphing quiz, didn't have a number on it. But anyway, it's actually our 9th quiz. Okay, so factor completely, factor this one by grouping. You can factor out an x squared from the first two terms. That would give you 8x plus 3. And then, of course, that's just 8x plus 3. You factor out the 8x plus 3. And then that would be times x squared plus 1. Now, you cannot factor x squared plus 1 because it's a sum of squares. Okay, the second problem is a sum of cubes. Now, you need to know the pattern for a sum of cubes, and you should have memorized this. A plus b times a squared minus a times b plus b squared. Okay, so the a part would be 2x. So uncubing 8x cubed would be 2x. Uncubing 125 would be 5. And then in the next parenthesis, it's going to be 2x times 2x squared, which is 4x squared. Then you multiply 2x and 5 and get 10x and change the sign, minus 10x, and then the last 5 times 5, 25. Number 3 is a difference of squares. So it's 4x squared minus 7, or plus 7, I don't care which one you do first, times 4x squared minus 7. Okay, now, does anybody still need this page? Okay, got it. All right, number 4 is a trinomial. So we want to do a regular factoring, except that it is to the 4th. So our terms in the first positions will be x squared. The factors of 16 that add to 10 are 8 and 2, and they both need to be negative. Next, since you have a difference of squares here, you want to check if either of these is a perfect square. 8 isn't a perfect square, neither is 2. So this would be finished unless you knew how to do factors of square roots, but we're not doing it. This one is a difference of squares, so this would be 3x plus 10 times 3x minus 10. Number 6, I'm going to factor out 4 first. You need to have done that. 4 needs to be factored out. So it'd be x squared minus 4x minus 16. Okay. And then you need to factor the trinomial. So that'd be x and x. Yes, did I do something wrong? Oh, of course, it's 6. Hello. Thank you for stopping me before I finish the problem. Of course, I have it in my key correctly. Duh. Anyway, the factors of 16 that add to negative 6 would be minus 8 and plus 2. Okay, on 7, that is also a difference of perfect squares. Don't let it bother you that there's a variable at the end. That's going to be x plus 8y times x minus 8y. Okay, anybody need this still? All right, number 8. What can I factor out right away? Always look for a greatest common factor. 3 and x to the third. Okay, so factor out 3x to the third. That would give you x squared plus x, and then minus 20. Okay. And then we got to factor the trinomial. So bring down your 3x cubed. It has to be part of your answer. Maybe x plus 5 and x minus 4. And that order doesn't matter. Excuse me, that looked weird. Okay, number 9 is a difference of cubes. The pattern is a cubed minus b cubed factors 2. A minus b times a squared plus ab plus b squared. It's So memorize that. 7 is to the third is 343. So this would be 7x minus 1 times 7x squared would be 49x squared. 7x times 1, negative 7x, but change the sign to plus 7x, and then plus 1. The next one needs to be by grouping. 3x cubed, when you have 4 terms, you want to try grouping them. When you put in a parenthesis in front of that minus 4x, you put it after the minus sign, therefore you have changed the sign of 4x to a positive. So you got to change the sign of the 20 to negative 20 or minus 20. Then I factor out a 3x squared out of the first 2 terms. It gives me x minus 5. From the second set, I factor out a 4. So 4 times x minus 5. Now the 2 big old terms have an x minus 5 in common, so factor out x minus 5. And what's left is 3 times 3x squared minus 4. Make sure you have these butted up to each other. That is supposed to be multiplication, not addition or subtraction. Anybody still need this? No. Okay. Number 11 says find the inverse. The first step for finding an inverse is f of x is like your y, is to switch x and y. Next, I solve for y, multiply by 4. Subtract 5. And divide by 3. So one way you could write it is 4x minus 5 all over 3. Okay, but I'm not writing it in the answer because I'm going to turn it around, which would be this part right here. This is the notation for the inverse of f of x. F to the negative 1 of x, that's the inverse of f of x. And then I would separate this out to a 4/3 x minus 5/3. Number 12 says to draw an example of a graph whose inverse is not a function. Okay, in order for a function to be a function, of course, it has to pass the vertical line test. Okay, for a function inverse to be a function, then the one you draw has to pass the horizontal line test. Okay. So since we want to draw a graph whose inverse will not be a function, we don't want our graph to pass the horizontal line test. We do want it to pass the vertical line test. Any questions about what I just said? Okay, we want the graph we make to not pass the horizontal line test. So what would be an easy one to do? A parabola. All right, I saw some hands. Thank you for raising your hands. So you can draw any parabola you want. Or you could make a loopy thing. So there's a lot of things, as long as it doesn't pass the horizontal line test. So I just made a quick picture. I mean, you could have something like this, which is a 4th power. Okay, these are just examples. So how do you know that the inverse of the graph is not a function? Now, what I just said a minute ago is why. Because this graph does not pass, okay, because this graph does not pass the horizontal line test. That is one way to say it. Or because this graph or this function does not pass the horizontal line test. Okay, good enough. Now we're on 13. Prove that f of x is equals negative 3x plus 6, and g of x, which is negative 1/3 x plus 2, are inverses. Show all work. You have to show the math. So this is saying do the f of g, which means the same thing as the f of g of x. Okay, that means put the g function into the f function. All right, so if I put the g function into the f function takes its input and multiplies it by negative 3. The input is the g function, negative 1/3 x plus 2. Then the f function also adds on 6. Okay, now I'm not going to do this one in the spot that's here. I'm going to do it afterwards, okay? So I'm going to keep working this out now. So I'm going to distribute to negative 3. Negative 3 times negative 1/3 would just be x. Negative 3 times 2 would be minus 6. So I have x minus 6 plus 6, and that simplifies to x. Okay, now I'm going to do the g of f, which means do the g of f of x, or put the f function into the g function. So into the g function multiplies its input by negative 1/3. The input is the f function, which is negative 3 times x plus 6. And then the g function adds on 2 afterwards, after multiplying by negative 1/3. Okay, so now I'm going to distribute the negative 1/3. That gives me x. Negative 1/3 times 6 is negative 2. Negative 2 plus 2 is 0, so we get x. You have to show all of what I wrote in order to get credit for showing that they are inverses of one another. Now, you had more space on yours. I just did it because mine was tiny. You could have done them all in one line if you like. It doesn't have to be vertical. Okay, simplify the following. When you do the simplification of this, you may wish to rewrite it so you don't make any mistakes. You want to distribute the minus sign, so you're subtracting 5x cubed. You're subtracting negative 8x squared, which results in adding 8x squared, and you're subtracting 11. Okay, now simplify by combining any like terms. The negative 5/3 x would be first. Do the highest power of x first. Combine negative 6x squared with positive 8x squared would be plus 2x squared. You have a 7x. And then you have 2, negative 11, so it's going to be minus 22. Okay, 15, if you're going to cube this, you cannot just say x cubed minus 343. No, thank you. That's not correct. This is x minus 7 times x minus 7 times x minus 7. I'm going to go ahead and multiply the last two first. I'm just going to bring down that first x minus 7, and then I'm going to multiply these out. X times x squared, x times negative 7, negative 7x. I'm doing the long way. Negative 7x and plus 49. Now, I did teach you how to do that quicker, and I hope that most of you would have just gone straight to x. I don't know why I didn't put a squared on that. X squared minus 14x plus 49. Okay, next. Now we're doing it this way because we did not go through the Pascal's triangle, the binomial expansion theorem, and there is another way to do it by patterns, but we're going to just go ahead and multiply them out since we're skipping that for time's sake. You'll see it in pre-calculus. So we got x cubed multiplying through by x minus 14x squared plus 49x. And then I'm going to multiply through by negative 7 and combine all like terms. So I got negative 7x squared next. And what's 7 times 49? 98 plus 98x. And then negative 7 times 49 would be minus 343, right? Yeah. Okay, combine any like terms to finish it. We've got x cubed. Negative 14x squared minus 7x squared would be minus 21x squared. 49x plus 98x is 1 is that 147x, and then minus 343. Wait a minute. I forgot something. Oh, no, I didn't. That's done. Anybody still need this page? Okay. Any questions so far? Okay, so this kind here, you're just going to have to take your time and do it out. Okay, 16. Neighborhood kids want to build a treehouse and decide to have a bake sale. The revenue, R of X, from the sale of X pies is given by R of X is 10X. Okay. R of X equals 10X tells you something. It tells you that that's your revenue, which means it's what you're charging. What are you charging then for the cakes? $10. Okay, that needs to be money, guys. $10. Okay, the revenue, now we already did the revenue. Now suppose the function for the cost of making pies is P. Why did they write? This should be C of X, not P of X. What have we been using P of X for? Profit, okay? I'm sorry. Don't know why that was a P there. C of X is 4.5X plus 15. Now that's the cost function. Okay, now I wrote them over there just trying to separate things from the word problem for a minute. What you need to do to give me the profit function, and I told you this on the last quiz, and a lot of you did not do this correctly. So let's get this straight. It's really not that hard. I think everybody can do it if they just practice here. We need to take, how do you get your profit? Well, you take, go ahead, Cole. That's right. You got to take your revenue and subtract your costs. Everybody who's in business has to do this, okay, to find out if they're going to be profitable and when they're going to be profitable. So what you have to do is take your R of X minus your C of X, which is what Cole just said. So I need that simplified, guys. 10X minus, in parentheses, 4.5X plus 15. You need to simplify that. I don't want to see that on this line. All right? I want it simplified. That's been the whole point of the chapter. I mean, the unit, one of the first section was adding and subtracting functions. So you need to go ahead and subtract it. Don't just write this on the line. Okay, so what's 10X minus 4.5X? Well, that's 5.5X. And then don't forget, here's where most of the mistakes came from on that quiz. When you subtract this, you're not adding 15, you're subtracting 15. You got to distribute the minus sign. Okay? All right, so this is what I expect for your profit function, a simplified function. All right, then, what's the profit for 50 pies? You plug in 50 into your new function. So you're going to do 5.5 times 50 minus 15. And that should give you a sum or a total of, I don't know, I didn't write it down. What is that, please? Wait, I got different answers. They were? Oh, I just couldn't hear them because we blended together. What was that? I'm sorry. 60? $260. All right. And I don't care if you don't have the change on there. All right, next section. Let f of x be x squared minus 1 and g of x, x plus 3. We've got two functions, and now we're going to do some stuff with them. You test to state any domain restrictions. You don't have to write the domain unless it has restrictions, okay? So when you add the functions, this one's parabolic. It's got a domain of negative infinity to infinity. And this one's linear, so it has a domain of negative infinity to infinity. So the new function, if you just add them, it's still going to have a domain of negative infinity to infinity, and we don't have to write it down because there aren't any restrictions. So this is just saying to add the two functions. So you're just doing x squared minus 1 plus x plus 3, which is x squared plus x plus 2. Simplified. You need to have it simplified. 18 says to multiply the functions. The f times g of x, you multiply x squared minus 1 times x plus 3. So you're going to have to FOIL this out or distribute twice. X squared times x would be x cubed. X squared times 3x squared. Negative 1 times x. And negative 1 times 3, minus 3. Simplify that. I wouldn't probably leave that 1 there, but this is already simplified. Done. Now this is different. This open hole stands for the f of g of x, which means put the g into the f function. Whenever you see one of these, you can rewrite it like this. You can put that parentheses in there. And all that means is put the g function into the f function. It doesn't mean multiply by x. That's not what that means. You're not supposed to multiply by x. You're just supposed to put the g function into the f function. If you do the f of x plus 3, which is what it means, you're putting x plus 3 and replacing the x in the f function with an x plus 3. The f function squares its input and subtracts 1. So the input is x plus 3. So we're going to have to square the x plus 3, and then we're going to have to subtract 1. Okay? So I squared this out by doing the shortcut method, x times x squared. X times 3, 3x doubled would be plus 6x. And then 3 times 3 plus 9. Okay, then simplify. Get x squared plus 6x plus 8. And now number 20, and multiplying them didn't change anything about the domain either. This thing still has a domain of negative infinity to infinity. And so did the previous one. Now when you divide, that's when you got to be careful. So the f divided by g of x would be x squared minus 1 on top, x plus 3 on the bottom. Now, I could factor the x squared minus 1 as a difference of squares, but it's not going to simplify anything because the denominator is not a factor of the numerator, so I leave it alone. But I have to give a restriction. The denominator x plus 3 cannot equal 0, and you need to finish that. So x cannot equal negative 3, which means the domain changed from negative infinity to infinity to negative infinity to negative 3, not including the negative 3, and negative 3 to infinity. So the only restriction is x can't be a negative 3. And that's because the denominator can't have 0 in it. Okay, does anybody still need this page? No? Okay. Okay, got p of x is the absolute value of 2x plus 3, and the q of x is 4 minus 2x. The first thing says to do the p times q of 7. So I would do the p of 7 and the q of 7, and then I would multiply them. All right, so the p of 7 is putting 7 into that absolute value, 2 times 7 plus 3. That's 14 plus 3, which is 17, and the absolute value of 17 is 17. Okay, that's not the final answer, of course. It's just part of what my process is to get there. The q of 7 means put 7 into the q function, which would be 4 minus 2 times 7, which would be 4 minus 14, and that is negative 10. Now that I have the p of 7 and the q of 7, I can multiply the results. So the p times q then of 7 is 17 times negative 10, which is negative 170. Now I wrote all the details out, and you don't have to write that much when you're doing it on your own. But I would write down for me what you got for the p of 7 and the q of 7, and then show the final answer. Okay? Yes, Ben? No. No. Because this is an absolute value. I guess so. I mean, yeah, I guess if you just went 4, I just meant I don't want you to try to distribute over a absolute value. So you did this, basically. or reverse. And you just stuck 7. Yeah, sure. That'll work. I've just been seeing some sign mistakes. So, okay. The Q of P of -2. All right, that would mean you have to do this in a certain order. Okay. You have to put -2 into the P function first. Okay, so I'm going to do the P of -2, and then what I get, I'm going to put into the Q function. The P of -2 is the absolute value of 2 times -2 plus 3. So the P of -2 would be, that's -4 plus 3, which is -1. The absolute value of -1 is 1. Okay, now you put 1 into the Q function and do the Q of 1. The Q of 1 would be 4 minus 2 times 1, and that's 2. So your final answer is 2. All right, 23. Sketch the graph. Well, I expect it to be better than a sketch. I want 3 accurate points because we know how to graph these parabolas. The domain should be -infinity to infinity. The vertex is at 0, -1. The parabola is opening down. So if you want to do -2 times 1 squared, do our 1 squared, 2 squared method. And that'd be -2. So you go down 2, right 1, down 2, left 1. And now you've got 3 accurate points. And I'll be happy with your graph. You can do it again if you want. -2 times 2 squared, though, would be -8. And I guess we can go down there. Okay, so this would be your sketch of your parabola. Okay, the range is from -infinity up to our vertex y value, which is at -1. And it does include it. Okay, the end behavior. The graph is pointing down on the left. So f of x is approaching -infinity on the left as x approaches -infinity. I would like you to do it left to right, if you could, please. The right side of the graph is also pointing down. F of x is approaching -infinity as x approaches +infinity. Left side, right side. Any questions about that? No? Okay. 24. Or did anybody still need that? All right. 24. Graph f of x and f inverse of x on the same graph and label. All right, the first graph, f of x, is 4x minus 2. So I'm going to go ahead and graph that. That's just a line that has a y-intercept of -2 and a slope of 4. Up 1, 2, 3, 4, right 1. 1, 2, 3, 4, right 1, and do several points. Okay, and then down 1, 2, 3, 4, left 1. 1, 2, 3, 4, left 1. Okay, so make a nice line. I'm actually going to grab my line tool. Oh, no, I don't want that. I'll just do a stick. Okay. And there's my nice straight line. All right, now I'm going to find the inverse of that. So to find the inverse, you switch x and y. So it's going to be x equals 4y minus 2. Add 2. Divide by 4. Okay, so f inverse, and I'm not going to leave it x plus 2 all over 4. I'm going to write 1/4 x plus 1/2. Well, yuck. The reason I say yuck is because I want to graph that using slope and y-intercept, but I probably wouldn't like that too much because of the fraction. Okay, so I'm going to make a t-chart because I don't like that. Well, I guess I'm going to have to add a half to everything, aren't I? Okay, so it'll be positive 1/2, and then up 1, right? 1, 2, 3, 4. I think the one on the quiz is a little nicer than this. Up 1, 1, 2, 3, 4. Or down 1, 1, 2, 3, 4. So they're all fractions. Kind of awkward. Hopefully I have a y-intercept on the quiz that's not a fraction. But this would be the inverse. Okay. Now, remembering some properties about inverse functions, these graphs are reflections over what? They're reflections over a certain line. You're supposed to know this. Y equals x. Yep. Which actually cuts the first and the third quadrants in half. That's their reflections over y equals x. It didn't say anything about that right here. I just wanted to remind you. You also should know that the inverse switches the domain and the range. X values switch with the y values, etc. So we could have actually graphed this line by taking the points we had here and then reversing them. So see how this was at 2, 6? We could have plotted 6, 2. Bingo, right there. Okay, so that's another way to graph that line. So we also had the point on here of -4, -1. Oh, that's the wrong one. Excuse me, I want to do my red one. 0, -2. So -2, 0 should be on it. It is right there. Okay, so another way to do this is to get nice points from this one and then plot them and graph the other line. Okay, but we had to solve for x once we've switched x and y. All right, find the inverse of this one. All right, first thing, step 1, switch x and y. Subtract 5. Multiply by the reciprocal of 2/7, or if you like, multiply by 7 and then divide by 2. If you multiply by 7 and then divide by 2, you're still going to get the same answer. You're going to divide each piece by 2, so it would be 7/2 x minus 35 halves. And then you should rewrite this at the, I won't make you write the inverse notation since that already said y, so just turn it around. Y equals 7/2 x minus 35 halves. Okay, study for your quiz. I'll take some other homework questions now if you like, but right now that is the end of the quiz preview. Does anybody still need this page?